In this lecture, we will start with a brief introduction to text data and its importance in the world of programming and analytics. Straight after that, we will try out several relevant hands-on applications. Let's start, shall we? Working as a programmer, it's highly likely you'll encounter text information in every project you embark on. Therefore, it is essential that you are technically prepared to manipulate text. To make sure we set off from the same starting point, let's clarify the distinction between text data and text files. Text files are files containing information from the text data type only. Examples of such files are JSON, CSV, HTML, and more. Text data, on the other hand, is information or data which represents text as opposed to numbers or Boolean, for instance. Clearly, a value such as no feedback has been provided as of yet is text data. Instead, the numbers 15 or 20.50 can be considered numeric data, while a true or a false value, Boolean data. All right. So, dealing with text data is an essential part of every field of application of Python. This might be working with APIs, web scraping, machine learning, or quantitative analyses, where you'll always need to quantify text data or other. All fields will require certain technical skills to convert the available text information into the appropriate format. Hence, to unfold the full potential of the relevant Python features or any of its libraries, you need to have certain text manipulation tools under your belt. So, let's not waste any time and start working with text. You'll often want to print out information stored in your Python objects as text. To apply this technique, you'll need the print function, a string value, an object, an argument specifier, and the modulus operator. Naturally, it will be much more intuitive to understand the essence of this task through an example. So, let's see one, shall we? We will begin with a Python string object. More precisely, we want the letter A to represent a product category. That's why we'll store the string A in a variable called product category. Fine. The idea is to print the following statement. This item is from product category A. However, we don't want to include the letter A within the final string directly. Rather, we would like to refer to that letter via the product category variable. But how can we do that? The answer is with the help of an argument specifier and the modulus operator. In the parentheses of the print function, we will specify the following part of the string we are trying to obtain. This item is from product category, full stop. Then we'll need an argument specifier just before the full stop. An argument specifier is a combination of symbols that indicates the place within the string where you'd like to insert information from a separate object, that is, the argument, and at the same time specifies the data type of that argument. Since we intend to insert the letter A into the existing text, we'd like our argument specifier to point out that the inserted value should be a string. A relevant argument specifier is written as %, lowercase s. It is important to note that if we execute the cell now, we will obtain %, s within double quotes at the end of the string. The reason is that the code we've written is not a clear indication to Python about our intention to see the letter A in the output. Therefore, we'll need the modulus operator after the second quote. In Python, the modulus operator covers several functionalities. When it comes to string formatting, it allows us to point to the variable from which we'd like to obtain information and insert it into the original string. Please note that this insertion will happen exactly in the place where we've provided the corresponding argument specifier. Conveniently, we use the % to write the modulus operator as well. Thus, we can syntactically and visually relate the product category variable to the place in the string where we want to insert its values. In other words, the % helps us make the connection between the data source and the final output more easily. Therefore, executing the cell now gives us the desired output. Great! With the structure we just used as an argument of the print function, we can easily change the final output to this item is from product category B. All we need to do is substitute the string A with B and rerun the cell. Excellent! The biggest advantage of this structure is that it allows you to refer to one or many values of a certain variable. So let's see an example where product category contains a list of string values, say A and B. If we run the cell after making this change, we wouldn't obtain a meaningful output. However, we can help ourselves with the indexing operator and specify which of the values of the product category list we are interested in. For instance, we can write 1 within the brackets and execute the cell. Such code will result in an output that reads, "This item is from product category B." Nice! %, lowercase s, is the combination of symbols that we use to indicate where we would like to insert not just a string, but also any value or object that can have a string representation, including numbers. Let's create a list called quantities and store 2 integers in it, 500 and 600. Then we can use the same argument of the print function we wrote earlier and substitute product category with quantities to obtain a valid output. However, there is another basic argument specifier that allows you to be more precise when indicating the type of value you intend to insert into your string. %, lowercase d, is the corresponding argument specifier for inserting integers, where the d perhaps derives from digit. In that case, a line like, "We currently have 500 available units of this item," sounds more meaningful. Let's see it in an example. In a print function, we'll need the following string. We currently have %, lowercase d, available units of this item. Then we can proceed with the modulus operator. Good practice suggests we surround this operator with a whitespace character on each side. To the right of this entire expression, we can indicate the list of interest, which is quantities. Then we can specify the value of 0 within the brackets of the subsequent indexing operator to indicate we want to obtain its first value. Execute, and we see that we currently have 500 available units of this item. Hooray! Analogously, we can use the %, lowercase f argument specifier to indicate that we want to insert float values. A relevant example would be storing stock share price values such as 40.5 and 60.35 in a list intuitively called stock share price list, and then refer to it in the argument of a print function in the usual way. Here, we can add a $sign before the %, lowercase f combination. However, provided that we refer to the second float value of this list, we will obtain a share price of 60.35 with 4 more zeros at the end. The reason is that by default, this particular argument specifier provides 6 digits after the decimal point. To specifically indicate the number of displayed digits after the decimal point, we need to insert more symbols between the % and the lowercase f. These symbols are a dot and, optionally, an integer. The integer shows how many digits we see after the decimal point. If we only have a %, a dot, and a lowercase f, we'll obtain a share price of $60. If we add .1, we will round the same value to $60.4. .2f will lead to the exact $60.35 per share, and so on. Lastly, we would like to discuss a structure that you might need if you are working with several objects containing multiple values each. Referring to the argument of the print function, in that case, you may want to use a variable within the indexing operators of quantities and product category, as opposed to a specific integer value. For simplicity, you can call such a variable I for integer. If you initially set I to be equal to 0 and execute the cell, you will obtain the phrase, "Currently we have 500 units of category A products in store." Changing 0 to the value of 1 for I and rerunning the cell will lead to an output using the second values stored in our objects. The result will be, currently, we have 600 units of category B product in store. Great! We hope you enjoyed watching this video. See you in the next one, and thank you for watching.